In previous classes, we started with a lesson light. We saw what is light, what are the sources of light. Okay, then what are the natural and artificial sources of light? Okay, hot and cold light. Now, difference between the frequency of light sources. Sources of light do not have equal light. Okay, now all sources, they do not have equal light. Some have more and some have less. Some shine more, some shine less. You must have observed that if source of light is far away from us, we see less shine in it. Okay, because less reflection takes place, we are only able to see less shine of the object which is far away from us. This we talked about. Now, categories of non-luminous objects. Okay, there are three categories of non-luminous objects. Okay, non-luminous means those objects which do not have their own shine. Okay, which do not have their own light. These are three types. Okay, on the basis of traveling of light. First is transparent objects. We can see through transparent objects. Okay, we can easily see through transparent objects. Why? Because light travels easily in these objects. Okay, these are the channels of light. For example, mirror, air, water, etc. These are transparent. Glass. Okay, these are all transparent and light easily passes through them. Okay, and reflects. Yes, Emma.
Haven't we done these three?
No, Emma, we haven't done transparent, translucent, opaque. Last time, we stopped at difference between frequency of light sources.
Yes, ma'am, but haven't we studied about this in another chapter also?
In another chapter also? No, not another chapter.
Okay, ma'am, maybe I have studied it before.
Yeah, yeah. You might have studied this before, probably. Now, can you turn on your video, Emma? Yeah, yes. Now, yes, so transparent objects, okay, light passes through them directly. Translucent objects, we can see through these objects, but it is unclear and dim. Okay, unclear means it is a little blur. Okay, why? Because they are not fully transparent, they are not fully clear. Okay, so only some light can pass through them. Only some light can pass through them. So that is why we can only see um, like blur image of something through translucent materials. They are like paper with oil spots, tracing paper, etc. Translucent glasses are also there to make to make the window panes or to make the doors of hotel washrooms and bathrooms. Okay, so translucent glass, like suppose if there's a translucent glass, okay, and there's a dark pink color, you can say jug on the other side of it. Okay, you can see from one side, you can only see the dark pink color, something is there. Okay, the size and the color only it will. You won't be able to see very clearly what is that. Okay, what is that, but you'll be able to see the color. Okay, and you'll be able to see that something is there, the size of it. Okay, but the shape and what exactly it is, you wouldn't very clearly know. So that's how translucent objects look when we see when we see through a transparent surface. That is how objects look like. Then we have opaque. We cannot see through these objects because opaque materials block the light that passes, that falls on them. Okay, they block that light. They stop the path of light. Even a single ray of light cannot go through them. Okay, if I hold a wooden pane, okay, I stand on this side, you stand on that side, we will not be able to see each other. Okay, why? Because the opaque objects are completely like they are not at all transparent, not even a little bit, not even translucent. Okay, and they stop the path of light, they block the path of light. Okay, so these are stone, wood, iron, aluminium, etc. Okay, these are opaque objects. Any doubt in transparent, translucent, or opaque objects? Any doubt here? No? Okay. Objects which have their own light are called dash
No,
objects.
ma'am.
Objects which have their own light are called dash objects.
Luminous objects.
Yes. Sun is the dash source of light.
Sun is a source of light.
Natural source of light. Light can travel easily through dash objects.
Ma'am, transparent.
Yes. Through transparent objects. Planets and satellites shine by the light of
Mm.
sun. Okay. All the planets, satellites, and stars. They shine by the light of stars. And sun is also a type of star. Maximum light sources emit heat with dash. Maximum light sources emit heat with light. Okay, or energy. Lights. Like they produce they produce light as well as heat. Okay, they produce light as well as heat, such as the sun. Sun is giving us light also, and sun is giving us heat also. Okay, now traveling of light. Light travels in fast speed from one place to another. Okay, it travels at a very fast speed. It travels at varied speeds in various mediums. Okay, so it there is a difference in the traveling of light or the speed of traveling of light when it passes through solid, liquid, or gas. Okay, they when light travels through these mediums, it travels at a different speed. Okay, light travels at varied speed in various mediums. It travels in water with the speed of 2.25 lakh kilometer per second. Okay, and it travels with a speed of 2 lakh kilometer per second in glass. Okay, means in water faster than it travels in glass. Light can travel in vacuum also. Vacuum means where there is no channel. There are around many hundred kilometers of vacuum between Sun and Earth. Still, sun rays reach Earth. The speed of light in vacuum is around 3 lakh kilometer per second. This is the most, okay, 3 lakh kilometer per second. You will be surprised to know that an item can move more far in the entire universe, okay? More far means than more further away than the sun, okay? This is about the traveling of light. Light travels in a single line in any one medium, in any medium, okay? Light travels in a single line in any medium. Medium means it can be water, in through glass, in vacuum, okay? It travels in a straight line, a single line. Keep a lighted candle on a table. Try to see the flame with a twisted rubber pipe. Now make the rubber straight and see the flame. Which mode helps in seeing the flame? The flame of light is seen when the rubber pipe is straight, and slight twist in the pipe does not help us in seeing the flame. This tells us that the light travels in a straight line. Okay? Light travels in a straight line. I twisted the pipe. Okay, so in this case, you're not able to see the flame. You're keeping the pipe straight. You're able to see the flame because light travels in a straight line. Many natural events takes place with light moving in a straight line, like making of images, lunar eclipse, solar eclipse, etc. Okay, these are the events where light moves in a straight line. Okay.
Ma'am,
Yes, Abraham, you're muted. Unmute and say. You are muted, Abraham.
on the twisty turn, if we add mirrors to it, ma'am, we'll able to see it clearly.
Yes, Abraham. Yes. Okay. Reflection. We'll be able to see it due to reflection. If an opaque object is placed in the way of light emitted by the source, then the other side of the object has a black shaped structure, which is its shadow. The shadow is prepared by the linear motion of the light. Okay. Now, what happens is that when we put an opaque object, okay, opaque means something that does not allow any light to pass through it in the path of light, okay, then the light touches its edges and gets like slightly diverted, okay, slightly diverted, and due to that, okay, due to this motion of the light, we see the shadow of that thing appear on the other side. Okay, on the other side. Now, the shadow is prepared by the linear motion of the light. Okay, linear motion, light travels in a fixed path in a straight line. Okay, linear motion of light. That is why shadows are prepared. Okay, this is the meaning of shadow. Now, reflection of light. You have already read that light travels in a straight line in a medium. This chapter has used a straight line as a symbol of traveling light. This light has been made in the shape of an arrow. A single line with an arrow in the end is called a ray. Okay, group of many rays are called beam. Okay. Now, when the light travels in a straight line, ray, okay, when many of these are traveling, this will be called as a beam. Okay. This beam is of three types. parallel beam, convergent beam, and divergent beam. Okay, parallel beam, when this one is the parallel beam, where all the rays are parallel to each other. Okay, where all the rays are parallel to each other. Then convergent beam, where the rays are coming from many directions but focus at one specific point, is known as convergent beam. Okay, convergent rays. And when the rays are, are going from one particular direction point in different directions, it's known as divergent beams or divergent rays. Understood? Understood what is parallel beam, what is convergent
Yes,
beam,
ma'am.
what is divergent beam. Okay, now when light traveling in a medium collides with any object, then the speed of light, according to the nature of the object, can be light collides with an object. Okay, if it is opaque, then some light is expanded and some is absorbed. Okay, okay. See, light collides with an object. If it is opaque, then some light is expanded and some light is absorbed. Okay, opaque objects. Some light is expanded, some light is absorbed.
Ma'am.
Yes, Abraham?
But I have there is something wrong about this when they're talking about light collides with another opaque object. Some light is expanded and some is absorbed.
Okay.
And the wrong thing is, ma'am, it depends on the color. If it's red, blue, if it's any of the color that like rainbow colors or any green or any color, light will get reflected from it. But
Mm-hmm.
some of this light colors are absorbed. That's why we get to see like the red part of the ray comes back and we see it. And the others are observed, ma'am. But ma'am, black is the only color that light when it hits it, it will not get absorbed. No, it will get absorbed. Or all the light particles will get absorbed. That's why we see things to be black.
Yes, Abraham, that is correct. Okay. That is very true. That is very true. That black color absorbs more of the rays. Okay. That is correct. Now, transparent objects absorb some light, some goes back and some goes through it. Sometimes we can see our face in the window pane. This happens because of window mirror, where some light is absorbed and some light passes through the object. The glass pane also absorbs sunlight. Okay. The transparent objects, I would say, okay, I would say the light goes through it completely. Okay. The light goes through the transparent objects completely. Okay. This would be how it look like for transparent objects. Completely light goes through them. Okay.
Ma'am,
Yes.
when transparent objects, light doesn't go completely through them. There's a part of the ray that get reflected. It's because this transparent, yeah, the light doesn't go completely through. As what I have learned is because, ma'am, that's the reason we can see reflections in the transparent objects. Not reflections, but we know there's a glass.
Mm-hmm. Yes,
But
Abraham.
our eye catches that other ray that has come.
Mm-hmm. Yes. So it happens like this. This is the incident light that is falling. Okay. Then there is the light that is reflected, and the light that is refracted. Okay. Some is absorbed and some light passes through the object. Okay. And here the reflection takes place. Some light is absorbed and some passes through it. Okay, the top one is reflected, the bottom line is refracted. Okay, so that is why we are able to see our reflection in the window pane. Okay, if the object is greasy and shiny, it cannot absorb light. Then the maximum light goes back after collision. The process of light going back after collision with the layer of an object is called regression. Okay, is called regression. I'll explain all of these to you in whiteboard also. Okay, like last time. I'll give you diagrams for each of the condition. Okay, I'll give you diagrams for each of the condition. Due to light regression, we can see own images and images of other objects in the mirror, steel utensils and other objects at the shiny surface. This is the beams, okay, parallel, convergent. This is parallel, this is convergent, and this is divergent beams or rays of light. Okay, understood now. I'll give you diagrams for each of the case. Okay, what happens when the light, like we shine the light on an opaque object, how it gets reflected, or what's the case that happens, and what happens to transparent, translucent materials. Okay, okay. From rules of regression, we will do tomorrow, and then we'll do real and virtual image. First, we'll do rules of regression and diagrams for these things, and then we will do real and virtual image. Okay, okay. Shall I take your doubts now, Abraham?
Ma'am, can you, I don't have any doubts in the science, ma'am. Can you ask, ma'am, can you help me with the inverse and direct proportion, how to calculate?
Yes, Abraham. 1 second.
Ma'am, how to calculate decimal proportion?
Yes, yes. 1 minute.
Ma'am, you had showed a method, ma'am. Can you show me how to do that method?
I showed you one method for it.
Yes, ma'am, some method you had showed me, us.
Okay. Okay. Okay, direct and inverse proportion we are having. Right. So direct proportion, for the direct proportion, when one thing increases, the other thing also increases. Okay. And one thing decreases, the other thing will also decrease. That is your inverse proportion. Okay. Like quantity increases, price increases. Okay. That is one example of your direct proportion. Okay. How to calculate that? Suppose you are having quantity and price. When the for 5 dozen oranges, the price is 120. Okay. For 7 dozen oranges, you have to find the price. Okay. So you can set up proportion equation first. Okay. For direct proportion, you can take the quantities together and the prices together. 5 is to 7. 5 is to 7 equals to 120 is to x. Okay. Multiply the extremes in the mean terms together. Okay. So 5 into x, 5x is equals to 7 into 120. X is equals to 7 into 120 divided by 5. Okay. How much? 5 from the cancel. Okay, multiply 7 times 24. Okay, 7 dozen price will be 168. Okay, now see, you can also use unitary method here. Okay, you can also do it using unitary method. First, you calculate the price of 1 dozen. Okay, and then multiply it with 7 dozen. Okay, calculate the price of 1 dozen and then multiply it with 7. How? How I'll show you. Okay, 5 dozen price is how much? 120. 1 dozen price will be 120 by 5. Okay, 120 by 5. How much? 24 rupees. Okay, now 7 dozen price will be 24 into 7. How much? Rupees 168. Okay, ever feel confusion? Ever feel doubt in the ratio equation, in the proportion, in forming the proportion equation? Do it using unitary method. Okay, you can do it using unitary method also. But if you are having like doubt, okay, if you're able to find it easily using this method, then use this method.
Ma'am, I find this easy too, ma'am. Because like it's about arranging it, right, ma'am?
Arranging it, Abraham. Okay.
Ma'am, if this
It's,
was inverse proportion, I would have to arrange it in such a way it would be one increase, one decrease, right?
yes, Abraham. Perfectly right. Okay. If it is inverse proportion, you have to arrange it in such a way that it is one increase, one decrease. Okay. And then you can find out the answer. Okay. Of inverse proportion. Okay.
Yes, ma'am.
Hmm. Now,
Ma'am, can you show me for inverse proportion?
yes, Abraham, we will do for inverse proportion also. Okay, we'll do it. Now, a cyclist is covering a distance 3.5 hours. Okay, distance and speed we are having. If he's covering a distance in 3.5 hours, sorry, time and speed we are having. Time and speed. Hours in with a speed of 10 kilometer hour. Okay. He increases his speed to 14 kilometer hour. What is the time taken? Okay. Now here, when the time,
This is direct, right, ma'am?
this is direct. No, Abraham, this is inverse. Okay, this is inverse. How inverse? See, when like you are going with the like bike, okay, and when you're driving with a speed of 50 kilometer hour, it's taking you to reach some place in 1 hour.
Oh, ma'am,
Okay.
so I understood. Because when you're driving with 3.5, uh, 10 kilometers, it's taking you 3.5 hours. But when you're driving
Hmm.
with 14 kilometers, a higher speed, it will take you lesser time.
Lesser time, yes. So increase in speed, decrease in time. Okay. It is a question of inverse proportion. Okay, we will arrange it. Okay, we will arrange it in such a way that increase in one quantity, decrease in the other quantity. Form the equation of it. 10 is to 14 equals to x is to 3.5. X equals 3.5. Okay, what you can do is you can convert 3.5 into a mixed fraction, oh sorry, into an improper fraction. 10 is to 14 is equals to x is to 3 to the 6 plus 1, 7 upon 2. Okay, or you can use 3.5. Okay, 3.5, 7 upon 2, both will do. Now, product of extremes and product of mean terms. Okay, so 14 into x, 14x. Okay, 14x is equals to 10 into 7 upon 2. Okay, you can also do 10 into 3.5. Okay, it is correct. 2 ones are 2, 2 fives are 10. Okay, how much?
Ma'am, 14x is equal to 35.
Yes, 35. X is equals to 35 by 14. Okay, 35 by 14. Now, you have to divide it and see. Okay, you have to divide it and see. You will get 2.5. Okay, you will get 2.5, 35 and 14. Okay,
So, ma'am, x is equal to 2.5.
you're getting 2.5.
Yes, ma'am, is because I cancel it first with 7, I'm getting 5 upon 2. And 5 divided by 2 is 4. So, 5
Yes,
divided
Abraham.
by 2 is 2.5.
Yes, 2.5. Okay, the value of x is 2.5. Understood? Okay. Now, this is how you work out inverse proportion and direct proportion. Okay, Abraham, this is how you work out inverse proportion and direct proportion. Set up an equation, okay, and then you find it out. Now, what was your other doubt, Abraham?
Um, I was supposed to ask how do I simplify decimals? Like in ratio and proportion, they give a ratio and then they give a decimal ratio and then they say simplify. How do I do that?
Do you have one question as an example with which I can show you?
Ma'am, just give me a second. I'm just one question.
Yes.
Ma'am, like it's asking which statements are true. They will give, wait, ma'am, when it asks which statements are true, it
Mm-hmm.
find the value of x in. Ma'am, when they find the value of x in the proportions, ma'am, we have to do the same, right, ma'am?
When they have to do find the value of x in the proportions, you just have to do the same thing, Abraham. Okay.
Ma'am,
These things.
will we take inverse or direct?
Abraham, just use the equation, okay, and do it as it is, okay. Like multiply the extremes, multiply the means, okay, and then just calculate x. Here it's you don't have to do anything with inverse or direct. Okay, you just have to find x. So they've already arranged the equation for you here. They've already arranged the equation. You don't have to rearrange it. You just have to do product of extremes into product of means and then find out x. Okay.
Okay, ma'am.
Then in which statements are true question, you can just same thing. You have to find out the value of extremes. You have to find out the value of mean, and then see are they equal or not. Okay.
Okay, ma'am. Ma'am, when they say find the mean product of the following extremes, we just have to find the mean, right, ma'am?
Yes, Abraham.
2 plus 8 upon 2.
Yes.
Okay, ma'am. I'm just giving you a decimal question that I found difficult.
Mm-hmm.
They're asking rupees 1.50 and find the ratio between the following. Rupees 1.50 and 115.
Okay. Rupees 1.50 and 115. All right. you can um, you can multiply both the numbers by 100. Okay, this is one method to remove the decimal. Okay, I multiply both the numbers by 100 to remove the decimal. The first one becomes 150. Okay, and the second one becomes 11500. Okay, now you can cancel and find out the ratio. Okay, cancel the zeros, cancel the zeros. Okay, now 15 and 115, you can divide it by 10. It won't be there. 5 you can do. Okay,
Ma'am, basically we have to simplify, right?
simplify it. Yes, basically you have to just simplify it. Okay, basically you just have to simplify it. 3 and 230. Okay, I think after this it won't be it's not possible to solve it further. 230 is not divisible with 3, so your ratio becomes 3 upon 230. 3 is to 230. Okay, first you remove the decimal. Okay, and then you just cancel it. Whatever you're left with will become your ratio. Okay, Abraham got it?
Yes, ma'am. Thank you.
Okay. Hello, Joshua. Good morning.
Hi, ma'am. Good morning, ma'am.
How was your trip?
Fine, ma'am. Thank you, ma'am.
Okay. Okay, so we are going to have the maths test now. Okay. And I'll send you the papers in the group. Okay.
Okay,
In
ma'am.
a, in a while, I'll send you the papers in the group. Tomorrow is the last day to submit it. Do it today. Okay. It's exercise 7.1 to 7.3. Okay. And do it and send it to me by tomorrow. Tomorrow is the last day to submit it. Okay, now we will meet on
Ma'am,
our classes tomorrow. Yes, Abraham.
ma'am, uh, all three of us wanted to wish you a happy Teacher's Day.
Thank you, Abraham, Emma, and Joshua. Thank you so much.
And ma'am, we all made a card for you online.
Okay. Wow.
So, you
Okay. So, do you want to share screen and show me, or do you want to just send it to me on WhatsApp? Okay.
I'm sharing screen.
Okay.
Your mic is off, Abraham.
Okay. Okay. Wow.
And thank you for teaching me, ma'am, for 2 years.
It's been a pleasure.
Ma'am, this is Jishua's slide.
Okay. Okay. Really beautiful. Can I have this? Can you all send this to me?
Yes, ma'am.
Ma'am, if you could send uh, your postal code and your address, ma'am, then we will send you a hard copy of it.
Okay. Okay,
Ma'am,
then.
this
Yes,
last
Abraham.
slide was Emma's idea.
This what?
This last slide was
Oh
Emma's.
God. No, miss, not my idea. Not my idea. Or only Abraham's idea, miss. Shared idea. Shared idea.
Okay. Let me just read it.
Yes, miss. This is very nice letter by Abraham. Abraham's written it.
Okay. Thank you so much for the card. It's really beautiful, for all your wishes, and I have had a really good time teaching you. Emma was one of my first students of the level C batch, well, when she joined last year. Then I met Abraham, whom I've been teaching for the last 2 years, and then Joshua. Very recently, I met you. Okay, and it's been a really good time teaching all of you all. Thank you so much for your wishes, and I wish you all the best for your future, all the best for your exams, studies, and all that you do in life. May God's blessings be with you. Okay, may you grow, learn, and enjoy life ahead. Okay, thank you so much for it.
Okay, ma'am.
Okay, ma'am.
Okay, then.
Thank you, ma'am.
Okay, you can just send me a soft copy. Okay, you can send me a soft copy of the card. Okay, I'll keep it with me. You can send it to me on my WhatsApp. Okay.
Ma'am, no, I can send you the hard copy, ma'am, if you just send me the address, ma'am. I have the hard copy.
Okay. Then I'll send you my address, Abraham. Okay.
Okay, ma'am. And
Okay then.
this was the reason why I canceled the Friday test.
Oh, this was the reason.
Yes, ma'am.
Okay. Friday was 5th, right?
Yes, ma'am. Happy Teachers
Yeah.
Day.
Thank you so much.
Later, Teachers Day, ma'am.
Thank you, Joshua. Thank you, Abraham. Thank you, Emma.
Happy Teachers Day. Thank you, ma'am.
Thank you. Thank you so much, all of you. Now we'll meet tomorrow. Bye.
Okay, miss. Bye,
Bye,
miss.
ma'am. Thank you,
Miss, you
ma'am.
will send the test later, right?
Yes, I'll send it to you in 1.5 hours or so.
Okay, miss.
Thank you, ma'am. Bye, ma'am. Thank you, ma'am.
Okay, ma'am. Bye, ma'am. Thank you, ma'am.
Bye, ma'am.
Bye,
Bye.
Abraham. Bye, ma'am. Lol.
Bye. Bye, Abraham. Bye.